Okay, so we are now doing the how-to guide to your first set of tutorials. Okay, so this is the how-to guide for 1.2 velocity versus time graphs, problem solving with constant motion. So let's do a couple problems, kind of get you ready for what you're going to have to do. Okay, so in these situations, in these tutorials, you're going to be given some red context, which is what you're supposed to start with, and you're given this information where you have velocity. In this case, you're given information for a velocity versus time graph. In some cases, you'll be given information for the position versus time graphs. In some cases, you'll just be given the numbers. And in some cases, you'll be given information on the motion diagram. And in your tutorial, sometimes you'll actually be starting with an equation that you're given, and you have to create the other stuff. So whatever you start with, when you're given information, you have to create all the other things. So from this velocity versus time graph information, we're supposed to create a position versus time graph. We're supposed to create a motion diagram. We're supposed to fill in these values for the final position, initial position, delta t, and velocity. And then we're supposed to create two equations. Okay? So starting with this, we have this velocity versus time graph. And it looks like we have two parts to the velocity versus time graph. We have a blue part and we have a black part. So it looks like the black part starts here at the 1 second mark. Well, and goes on to 4 seconds, while the blue part starts at 0 seconds to 1 second. And it gives us this information. Our starting position is -10 meters. So it doesn't matter what order you want to do this, you just have to complete all of this. So let's actually start with the position versus time graph. Let's do this the most difficult way. And I'm going to use blue. So it starts right here. Now we have to figure out where it's going to end up at the 1 second mark. So it looks like it has a constant velocity of -2 meters per second. -2 meters displacement for every 1 second. So it's going to be traveling. So after it's going to be traveling to the left 2 meters over the period of 1 second. So it looks like it's probably going to end up right here at the -12 meters mark. Okay, so that's going to be its final position, because starting here, it's going to travel to the left, so it's going to end at the 1 second mark at -12. Because that's 2 meters to the left of -10. Okay, and then it looks like something happens, and now it's traveling +4 meters per second across. So this is +4 meters displacement for every 1 second. So it's going to travel to the right 4 meters for one at 4 meters, and another 4 meters, and another 4 meters. Across these 3 seconds, from 1 second to 4 seconds. So starting from -12, it's going to go to the right 4, so that'll be right here. So at the 2 second mark, it should be about right here. So hopefully this will end up being a straight line. And then it's going to go to the right 2 more. And then it's going to go the right 2 more. So it should look like a straight line going down to there. There you go. Okay. Cool. Cool. All right. So we filled out our position versus time graph. Let's put the numbers in. So for the blue part, it looks like it's traveling at -2 meters displacement for every 1 second. And it does that over a period of 1 second. And we said it's going to end at -12. And so just off to the side, so the displacement for that first part is going to be negative 12 minus a negative 10 minus negative 10 meters. So that's going to be negative 2 meters displacement. All right. Yeah. So its total displacement from beginning to end is going to be negative 2 meters. Okay. And I'm just kind of doing that off to the side just to make sure that delta x over delta t, which is 1 second, so that's negative 2 meters per second. Just double checking things, make sure it's not necessary to do that. Now for the black part, it looks like it starts off at the negative 12 meters, and it looks like it's ending at the 0 meter mark. And so it has a constant velocity of positive 4 meters displacement for every 1 second. And it does that across 3 seconds, right? 4 seconds minus 1 second. So it's a total time of 3 seconds. All right, let's put this into our equations. So the blue equation, trying to predict final position. So that's going to start off with velocity, which will be negative 2 meters displacement for every 1 second. Delta t. Whoops. Delta t. And that's going to be starting off at negative 10. And so for our other position equation, that's going to be x final. That's going to be positive 4 meters displacement for every 1 second, delta t, and it starts off at negative 12 meters. Okay. And they want to figure out the total displacement from beginning to end for the average and average velocity. Okay, so total displacement, let's do that. Pretty easy to answer this question. So from beginning to end, it starts here at negative 10. It ends at positive 1. So I'm going to do this. X final is going to be 0 meters. X initial, it started out for the whole trip at negative 10. And so for the whole trip, delta t was 4 seconds. And for the velocity is going to equal displacement over time. And so the total displacement, you know what, I'm going to do this right here. Velocity is going to be equal to displacement over time. And the slope of this is pretty easy. It's starting here, 1, 2, 3, so 2, 4, 6, 8, 10. So 0 meters minus negative 10, so positive 10. So the graph says positive 10 meters displacement over the period of 4 seconds. So the displacement is delta 10, delta positive 10 meters. And the velocity is going to be whatever positive 10 meters over 4 seconds is. So I do think they want a numerical answer. 2.5. So this is going to be a positive 2.5 meters per second. Meters for every 1 second. So this is what they're looking for. So let's go ahead, and from all the information we had, we're going to do our motion diagram. And so I'm going to do this and we only have to do the motion that's given. We don't have to do the whole trip. So starting off, it starts off at negative 10 meters. And I didn't give you the whole thing. I do on the tutorials, but not this. So at 0 seconds, this is 0 seconds. And then it's going to end at negative 12 after the first second. So negative 12 meters. And so that's after the first second. So this is 1 second mark, and this is negative 12 meters. So this is the velocity for the first part. So negative 2 meters per 1 second. Feel free to write really small if you need to. And then starting out at the 1 second mark, it's going to end at the 0 second, at 0 at the 4 second mark. So this is the velocity, and that is positive 4 meters for every 1 second. So 1, 2, 3, 4, that's from 1 second to 2 seconds, 2 seconds to 3 seconds, 3 seconds to 4 seconds. You don't have to draw all that. You could just draw just the given information. Okay? So that's what you're supposed to do when you're given the velocity versus time graph information. If you're given the position versus time graph equation, like in this case, you basically have all the information, and you've done this before. And again, you could do this in whatever order that you feel like, which is easiest for you. Luckily, this isn't 2 different pieces of information, it's just one. So it looks like it's starting off, and I'm going to start off with the numbers here. So it starts off at the negative 3 meters. So that's the initial position. And I'm going to put this as my initial dot, and this is going to be 0 seconds. Okay. And then it looks like it's going to end over here at the positive 1 meter mark at the 4 seconds. So this is going to be positive 1 meter right here, positive 1, and it's going to take 4 seconds to do this. So again, velocity is displacement over time. And so we could figure out the displacement pretty quickly, because it starts here at negative 3 and ends at positive 1. So that's going to be 1, 2, 3, 4. So that's going to be a positive 4 meter displacement, right? Because velocity is displacement over time, delta x over delta t. So the displacement is going to be positive 4 meters displacement over the period of 4 seconds, right? You don't have to do all this, but if you're paranoid like I am, you got final, x final minus x initial. So x initial is negative 3 meters. Got to make sure you put those in parentheses over the period of 4 seconds. So positive 4 meters displacement over 4 seconds. All right, so that's, I'm going to actually just reduce that down. That is just positive 1 meter for every 1 second. So I'm going to just put the final answer here. So that's just positive 1 meter for every 1 second. So positive 1. All right. Let's construct our equation. Well, actually, let's do the velocity versus time graph. So it's traveling at a constant velocity of positive 1 meter displacement for every 1 second, right? So it should start off at positive 1 meters per second and end at positive 1 meters per second. So pretty easy. Now let's construct our equation. So it's going to be a positive 1 meter displacement for every 1 second, delta t, and it starts off at the initial position of negative 3 meters. Okay. Now the problem is asking for what's the final, at what time does it have a position of 0 meters? So when is it crossing this 0 meter axis? And it looks like not quite at 3, but pretty close to 3. So I don't know. We'll find out. So we're going to put in a final position of 0. And this is going to be positive 1 meter over 1 second. And we're going to be solving for delta t in this case. So this is the best way I know how. So we're going to add that 3 onto the other side. So positive 3 meters. And that's going to be equal to positive 1 meter per 1 second, delta t. And then we're going to multiply both sides by 1 second. And then divide both sides by positive 1 meter, delta t. So the meters are going to cancel out, and we're going to get 3 times 1 second. So I should have just trusted myself. And so it does cross at the 1 second mark, at the 3 second mark. That drawing is not exactly accurate, but did my best. All right. So that is what to do when you have a position versus time graph. Now, in this case, they actually give you the numbers and they want you to figure out a few things. They give you initial position, final position, and the total amount of time, which is 4 seconds. I think all of these are 4 seconds. They want you to construct the 2 equations. They want you to construct the motion diagram. They want you to solve for velocity. They want you to create a position versus a position linear fit, position versus time linear fit, and they want to again ask you to what happens at what time is it crossing the 0 meter axis. Okay, so let's put in our numbers. Start off here, and let's actually figure out what the velocity is. I don't know why. It doesn't matter where you start. You could start off with the motion diagram. Looks like it starts off at the negative 2 meters per second, at the negative 2 meters per position at 0 seconds. And after 6, it ends here at the positive 6, and that's going to be at the 4 second mark. So here is our displacement and velocity vector. And that looks like it's going 2, 4, 6, 8, positive 8 meters over the period of 4 seconds. Let's just figure out what the displacement should be over time. Let's do it with numbers. Again, it's going to be final position minus initial position, delta t, which is going to be the period of 4 seconds. So this is also positive 8 meters over the period of 4 seconds. So positive 8 meters over 4 seconds, what is that? Positive 2 meters displacement for every 1 second. So this is going to be positive 2. Okay, let's construct our position versus time graphs. Position versus time graphs. So it starts off at negative 2 at the 4 second mark. It's at positive 6. So here's our position versus time line, which I can't draw a straight line for some reason. Let's try this. There we go. Hold the shift button in Microsoft Whiteboard as you draw. All right. On a velocity versus time graph, it looks like we have a constant velocity of positive 2 meters per second for every 1 second. So let's make that a nice line there. And for our equation, trying to predict final position, which is 6 meters, we already know that. But this is going to be a positive 2 meters displacement over the period of 1 second, delta t, minus 2 meters starting position. So to figure out what when it's crossing that line, we're going to have this as our equation where we're crossing the 0 meter mark. and we're going to solve for delta t, just like we did in the last problem. And so add that positive 2 onto the other side. And then we have this for 1 second, delta t. So we're going to have to multiply both sides by 1 second, divide both sides by positive 2 meters. So basically, we're going to multiply the entire equation by 1 second divided by positive 2 meters. That'll cancel out this side, and then it'll go on to the other side. So we got positive 2 meters over, so times 1 second over positive 2 meters, and that's going to be equal to delta t. And so 2 meters is going to cancel out, and so that's just at 1 second. Okay. Finally, you're given a displacement versus timeline. So you're given a motion diagram, and you're supposed to construct everything. This might be the easiest one of all because we've been doing this a lot. So in this particular problem, it looks like it is the last problem. It looks like it starts off at a negative 2 meters. Oops. And ends at positive 6. And this is a period of 4 seconds. So again, this is going 2, 4, 6, 8. Positive 8 meters over the period of 4 seconds. So this is again positive 2 meters for every 1 second. So I'm going to put a positive 2 there. And then our motion diagrams, our velocity versus time graph, that's pretty easy to draw. That is that constant velocity of positive 2 meters for every 1 second. And then over here, it starts off at negative 2, ends at positive 6. So there we go. And then x versus t. I'm going to start way over here because, like you, I want to try to do this all on this. I don't have a lot of room, so this is going to be positive 2 meters for every 1 second. Delta t minus 2 meters, and even though we just did it, I'm going to do it again. So we're going to set 0 meters, and this is going to be positive 2 meters for every 1 second. Delta t minus 2 meters, which is going to be positive 2 meters, equals positive 2 meters for every 1 second, delta t. Then we're going to multiply both sides by 1 second to eliminate it from this side, and divide both sides by positive 2 meters. And so when we do that, we're going to get positive 2 meters on the left side times 1 second over positive 2 meters is equal to delta t. And cancel that out, and you just have 1 second. And so that's how you do your first tutorial. Okay. There will be a quiz to go along with this first tutorial. We're going to have to put some numbers in. For example, in this first one, things you're going to have to fill in on the quiz are these numbers right here and these two values. What it's asking you to solve for. And then you're going to have to turn in your work, so you would have to take your work that you've done. Hopefully you've done it on a tablet. That way you could just turn it into a PDF and then turn this in. Okay? And if you want more information on that, you could go to the course where it says how to turn in your work through a PDF. There's a lot of ways to do that, but go to that section. All right, I hope you have a great day.